How do we measure electricity? We've already established that electricity carries energy, electric potential energy. So there are similarities between mechanical energy and electric energy. When you're analyzing the motion of a ball that's free to roll down a ramp, if you want to know how much energy that ball has, if you want to know its gravitational potential energy, you would measure its height and you would measure its mass and then use the acceleration due to gravity. You would calculate potential energy, gravitational potential energy, through the formula potential energy equals mgh. So you could then say, okay, this is how much energy the ball starts with throughout its path down the ramp. That potential energy will gradually change to kinetic energy, but the total amount of mechanical energy will stay the same. Similar rules apply for electricity. If you want to know how fast the ball accelerates down the ramp, you would have to consider the slope of the ramp. How steep is it? Is it a very steep slope or a very gentle slope? And that would tell you how quickly or how slowly the energy would be transferred. Gravitational potential energy and electric potential energy have similar properties. With electric currents, you can also measure how much potential energy there is, and you can also measure how easily or how quickly that electric current is able to flow through a circuit. Here we see two images. In each of these images, we have a battery. We have a wire attached to the battery on both terminals, and before the electric current enters the light bulb that's also in each image, it passes through a cylinder. On the top image, we see a copper cylinder, and on the bottom image, we see a cylinder made of a metal alloy called nichrome. And then on the right side, we have a measurement device called an ammeter. An ammeter is used for measuring current. So in these images, the electrons will move through the battery, through an ammeter, and then also through the light bulb and the cylinder. Copper and nichrome are different materials, and so the electric current will travel through these two materials at different rates. The rate at which the electrons or the electric current travels through this circuit is measured by the ammeter. That's the measurement of current. Remember, current is measured in amperes or amps. And we can see on this diagram the current is higher in the circuit in which the electrons pass through the copper cylinder than in the circuit where the electrons pass through the nichrome cylinder. What does this tell us? Well, this tells us that the electrons move more quickly and more easily through copper than they do through nichrome. This is why we make wires frequently out of copper. Here we see a heating element. When electricity moves through a heating element, like these metal coils of a toaster, they actually cause those coils to heat up and give off heat and light. The same way that when they go through a filament of a light bulb, they'll give off light and heat. Of course, on a toaster, we're more interested in the heat, and in a light bulb, we're more interested in the light. But this is because this happens due to a lack of, or a low efficiency in the flow of electrons, which is the same as low efficiency, say in a car engine. We have a conversion of chemical energy, chemical potential energy, to kinetic energy, and all that heat that's generated in a car engine is waste that reduces the efficiency. Well, the heat that's generated when electricity passes through certain materials, it also makes that flow of electrons, that flow of current, less efficient. But in this case, it can actually be useful energy, because in this case, we want to generate heat. So heat is our usable energy. When electrons do not move easily through a material, then that's when heat is generated. And that relates to a concept called resistance.